calculate the number of potassium ions present in 25.0 grams of potassium carbonate. Assume full dissociation in an aqueous solution. Okay, so firstly we need to calculate the molar mass of potassium carbonate. So capital M to represent molar mass is equal to 2 times the relative atomic mass of potassium, which is 39.10, because even though we're dealing with ions, we still need to consider the relative atomic masses of the elements present within the compound. So we add to that the relative atomic mass of one carbon, which is 12.01, and we add to that 3 times the relative atomic mass of oxygen, which is 16.00, and we get an answer of 138.21 grams per mole of potassium carbonate, so that is the molar mass of potassium carbonate. Okay, next we need to work out the amount in moles of potassium carbonate present in the solution. So lowercase n to represent the amount in moles is equal to the given mass of the sample, which is 25.0 grams of potassium carbonate, and we divide that by the molar mass of potassium carbonate, so 138.21 grams per mole of potassium carbonate, and we get an answer to 4 significant figures of 0.1810 moles of potassium carbonate. Next, we need to work out the amount in moles of potassium ions present. Now, according to the chemical formula for potassium carbonate, in each formula unit there are 2 potassium ions. So to work out the amount in moles of potassium ions present, we need to take our value for the amount in moles of potassium carbonate, 0.1810 moles, and we need to multiply it by 2.00 moles of potassium ions. And we're going to get an answer to 4 significant figures of 0.3620 moles of potassium ions present within the solution. Finally, to work out the actual number of potassium ions present within the solution, we take the amount in moles of potassium ions present, 0.3620 moles of potassium, and we're going to now multiply that by Avogadro's number. So the 4 significant figures, Avogadro's number is 6.022 times 10 to the 23rd, and we're going to give our final answer to 3 significant figures because the value we're given initially for the mass of the sample is in 3 significant figures. So we're going to give our final answer also in 3 significant figures. So our final answer is going to be 2.18 times 10 to the 23rd potassium ions.